Continuing with the transformer sequence network for the zero sequence currents. In the last session, we were seeing that in the positive and negative sequence diagram, it is represented by its positive and negative sequence, the reactances. However, the configuration for the zero sequence network for different connections will differ depending upon the grounding of the primary and secondary of the transformer. That also we are seen in the case of star with the star grounded, and there is a break because there is no complete for the zero sequence current, and we are seeing that there is star star both grounded. There is a path from P to Q and it is shown as P to Q. There is a path for the diagram. Similarly, we are seeing the for star grounded and delta. Here there is a flow of current in the P, however it is not going out of the delta, only it is circulating inside the delta. Therefore it is shown here there is a it is grounded from P to grounded here. Then in the case of star delta, as such there is no the flow of zero sequence current because neither it is a star grounded, therefore it is connected in delta. Therefore there is no existence of the zero sequence current itself. Therefore you can show the break between P and the Q here. There is a P and Q, and there is no flow of the current towards the ground here because of it is not grounded. There is no existence of zero sequence current. That is what we are seeing. And in the case of the delta, there is a current is the zero sequence current. They are circulating inside the delta because it is offering the delta connection is offering very high the impedance, because as such there is no return path. Therefore the zero sequence current they are flowing inside the loop itself. That is, it is represented here. Then this sequence diagram you have to realize with the switching diagram, simple switching diagram, that what I am demonstrating here. That is, I am considering once again, you can take it is from P to Q, it is any configuration. Just this P between P and Q, you have to represent zero sequence impedance or reactance. Therefore, I am taking here Z0 as a zero sequence impedance of a transformer. Then I am using here the four switches, that is A and B are called as a series switches, C and D are shunt switches. Then what do you mean by this switch? That is, the depending upon the following the instructions, you have to close the switch depending upon the connection of the primary and secondary. That is, switch A and C is meant for the primary side. A and C are meant for the C side, primary side, whereas the B and D it is meant for the secondary side. That we'll see now. That is, A and C they are meant for the primary side, and B and D are meant for the secondary side. That is, switch A in the primary is operated, that is closed only when the primary is star connected and grounded. The same thing is written here, grounded star close A. It is a primary side. It is meant for only the primary side. It is a primary side. When the primary is the star connected, primary is star connected and it is grounded, star connected and grounded, then you have to close the switch. Otherwise it is open. Okay, the same similar type of the instruction that you are realizing here, that is we can see here. I am going for the second point on the here, that is, if the primary is star connected and grounded, you have to close A. Then if it is star grounded and the C is meant for, if the primary is connected in delta, you have to close C. If the primary is connected in delta, then you have to close C. In that case, A is kept open. A is only one switch you can operate. Either A or C have to operate in the primary side. B and D they are operating in the second side. Any one of the switch depending upon the connection. If star connected grounded, close A. Otherwise you have to keep it open. That is over. If it is star connected grounded, close A. If it's star connected ungrounded, A is also open, C is also open. The same thing is written here. Grounded star, close A. If it is a delta connection, you have to close C. That is, this switch should be closed. This switch should be the closed. Okay, that is A and C is meant for primary, B and D is meant for the secondary. Then the another third case in the primary side, ungrounded star. It is the primary side is star connected, but it is ungrounded. It is ungrounded. That is, I'll show you all the three configuration for the benefit. That is, if it is star connected and it is grounded, then you have to close the switch. That is, primary side is get over. Okay, if it is only star connected, only if it is star connected, just I will rub it off this connection. Okay, then if it is star connected, then you have to, then this switch A should be open because it is star. Star is meant for A. The delta in the primary side is meant for C. Okay. Now it is star connected and it is ungrounded. It is ungrounded. This switch should be open. This switch should be open. Okay. In the third case, we can see here, that is, if it is a delta connection, then what you have to do? If it is a delta connected, you have to close C. That is, you have to close C. That is, if it's star grounded, close A. If it is delta connected, close C. If it is star ungrounded, you have to open this. Also, you have to open this. The same application, the statements is holds good in the secondary side also. That is, you look into here in the secondary side. If the secondary side is also grounded, if the secondary side of the transformer is grounded, and close the switch B. Okay. If it is the delta connected, and close D. If it is star connected ungrounded, you have to keep it both open. It is open. Both are open. Based on this particular statement, just you have to look into how you can draw the sequence diagram for different configuration. Therefore, I am looking into the next slide, that is where okay, look into this particular diagram. Then I am starting with the different configuration, then how to draw it, just I will demo here. Okay, the first diagram what I am considering here is star grounded, primary, and secondary is only star. Just you have to concentrate on the primary side first. Primary side, it is star connected, and it is grounded. Therefore, switch A should be closed. Then that is get over. Primary is get over because A is grounded. Therefore, it is closed. That is over. You don't bother about the C because C is only coming to existence. Only it is a delta in the primary. And you move to the secondary side. It is star connected. Star connected means it is switch B. Then whether it is grounded, it is not grounded. Therefore, it should be open. Okay. Then there is no question of C and D because C and D is meant for the delta. Only it is star means you have to concentrate on A and B switches. A is closed because it is star grounded, and the secondary, that is a switch B, is open because it is ungrounded. Therefore, in the sequence diagram, it looks like this. That is, there is a path from P to Z0, and however, in the secondary it is not flowing. It is not flowing. This is how you have to draw the sequence diagram for star star. That you can observe in the in the diagram that I'll show you. That is where already that is you are made in this diagram. That is was shown here. See here. In the star grounded and star, there is a P and there is a Z0 and there is a break here. The same thing as shown here in our switching diagram. That is, it is P, Z0 and Q. Okay, this is for star grounded and it is secondary star ungrounded. Now we'll move to the next configuration. We'll move to the next configuration, that is both are star primary and secondary are star connected and they are all grounded, both are grounded. Okay, that is the primary is star connected, it is grounded. The secondary is also grounded. Means star means you have to concentrate on A and B, and it is grounded means A and B are closed. A and B are closed. That's all. Finish. Then C and D should not operate because it is meant for delta connection. Therefore, if you are removing these two connections, then what we are getting here is that is switch A is closed, switch A is closed, and switch B is closed. Therefore, this is a sequence diagram for zero sequence network for star star, both are grounded. Okay, now we'll move into the next configuration. You can take it as star and secondary is delta. Star and secondary is delta. Now you can carefully see here. In the primary side it is star grounded, therefore A is closed, that is over. Then there is no operation of C here because it is already taken care star and therefore the switch A is closed. Secondary is delta, therefore you have to operate this D. It is operate this D, that is you have to close the switch D. Then there is no question of C and B switches here, they are kept open. Therefore, just you have to look into what you are operated. You are operated A, you are closed A here. Then you are operated D, therefore there is a direct connection from here to here. Therefore, the sequence diagram is P to Z0 and it is grounded here and there is a break here. This is a sequence diagram for star delta. Then if we are moving into the next diagram for the star and delta, both are, that is star is ungrounded, secondary is delta. If it is star and ungrounded, that is if it is star it is open, there is no question of the C here. Then secondary is delta, therefore you have to close the switch D, but however there is no connection here, there is no current is flowing here, then as good as this Z0 is isolated, the isolated from both P as well as it is the Q. It is isolated from P to Q. What we are interested is between P and Q, what is the connection diagram. Okay, even though if it is grounded here, then it does not serve any purpose. In this case, it is the both here, it is a open, it is also the open. Okay, you need not show this particular diagram because it does not make any sense here. Even though if you are connecting here, it does not make any connection. what you are interested is between P and Q, then therefore you can neglect this. Therefore what I am doing here in the this particular diagram, in the star and ungrounded, the secondary, that is what I am showing here is this diagram, that is both are open here, both are open here, both are open here. Then in the last configuration, just what I am showing here is for delta delta connection. That is a interesting. You can look into the delta delta connection. Delta delta connection. Both primary and secondary, they are connected in delta. In this case, the primary is delta, therefore you have to operate the C. I am shorting this is C because it is a delta connected in the primary. Then the secondary is also the delta connection, therefore I am closing the switch. This closing the switch, therefore A and B are open. A and B are open. These are open because it is both primary and secondary are the delta connection. Therefore then the circuit is means from here to here there is a connection here, from here to here, here to here. The same connection I am making here, that is from here to ground, then here to ground. Why? Because I am closing the switch C and D because both are delta. This is a sequence diagram for the delta delta connection. This is how you have to connect the sequence diagram for the transformer under different connections in primary and secondary, delta delta, star delta, delta star, with ground, without ground. Okay, the same thing that is in the last class I demonstrated in the form of a table. The same diagram, just I review here, just you have to look into. Okay. Okay, you can see here, that is in the star grounded and star, there is the gap here because the current is entering into here. That is the series switch B is open because it is star connected and is ungrounded, therefore it is open here. And there is a open in the parallel circuit because it is both are star connected, both are star connected, both are star connected, both are star connected. Therefore there is no question of the parallel connection, therefore there is a gap you are shown here. Similarly, if you are looking into the second configuration, it is star star, there is a complete path. Then what we are seeing here is there is a complete path. Okay, therefore there is a connection here. If you are taking star delta, that is previous slide, I will go once again. Okay, here you can see here there is a complete path here, therefore both switch A and B are closed and C and D are open because it is star star, C and D is open, A and B are closed, therefore what we are seeing here. And in the next configuration, that is what we are seeing here is star delta, and here the A and D are closed, therefore you are getting this diagram. In the next configuration, that is star delta, then as such there is no complete path, therefore it is shown as isolated. In the third case, the last case, that is it is a delta delta, then switch A and B are open and C and D are closed, therefore we are getting this time. This is how we have to draw the series sequence network for the transformer.